Thank you, Maria, and thank you all for being here. So we really live in remarkable times. While researching this talk that I'm having here today, the world as we know it is about to change. I stumbled upon so much research and so much development that is happening on a daily basis that the title itself is actually wrong. The world is changing as you're sitting here and I'm standing here. And I'm, as Maria said, Conny Svensson. I'm head of AI at CGI Sweden. We're one of those companies that are building these new platforms, these new solutions that are changing the world. But we have so much ground to cover here, so let's get into it right away. And I wanted to share actually two stories that with developments that happened just in the last month here, just to show what is happening here and get the feeling of remarkable progress. So this thing, straight from a science fiction movie, really. The term suspended animation is something that you do when you're traveling to faraway planets. You lower the body temperature so you don't really consume that much energy or oxygen. And this has now actually happened for the first time in real life, not in science fiction anymore. And that is really not to travel to distant planets, but more when people come into trauma, they've been maybe a knife wound or gunshot or something. And usually it's you have 5 minutes to operate on people, and the chance to a successful recovery is 5 to 10%. So what they really need is to buy themselves some time. So what they do is they pump the patient with ice cold saline into the blood system, and that actually lowers the body temperature to 10-15 degrees. And this stops almost all chemical reactions, and you're almost clinically dead actually. And that gives them 2 hours to operate, and the chance of survival is much higher. And then they pump in new blood, and they raise the temperature, and they kickstart your heart. And this has now successfully been done once, and hopefully more times than that. So now we can really, also travel to distant planets. Another really interesting thing is this. We now reach quantum supremacy. Quantum supremacy, the definition is when we find a problem that only a quantum computer can solve and not a traditional computer. Quantum computers are really it's not a new concept, but they're really hard to program. They're using qubits instead of bits, and they're kind of built with photons. It's really complicated stuff, and also very beautiful things. It looks like some kind of steampunk engine here. I think it was Google that a month ago announced this, and it solved a algorithm that took it 200 seconds, and for the best supercomputer in the world, that is from IBM, would take it 10,000 years. And of course, IBM came out and said, that is not really fair and so all that. But I think we reached quantum supremacy. So now we can kind of freeze our bodies. We can do all kind of really advanced mathematics. So you all know the Gartner hype curve. It's, new technology, what is in the front and what is kind of hyping and what is declining and what is maturing. And I mean, looking at what is on that curve right now, everything is based on AI technology in some sense. And in practicality, it's all about machine learning models, statistics, or deep learning models. So really, AI is the foundation of the future. Everything that we will see from now on is based on AI in some sense. And Gartner has also grouped those new trends in 5 different categories, and I will talk a little bit about some of them here today. And I think probably a lot of you have already kind of dabbled with AI. You tried different demos, proof of concept, but you haven't really scaled it up. It's when we build AI into our foundation of our companies in the society that we will see the next big transformation. And that is really something that I'm trying to get across here today. So looking at digitization that we've now done for a couple of decades, we really changed how we do work. This is an architecture office, probably in the 70s. A lot of white men in white shirts and one crazy dude in a blue shirt there. He didn't get the memo of the dress code, but Today, you have sitting in front of monitors with the CAD station. You're not just drawing; you're also testing for stress testing, resistive strength, and you can do all these things and calculations. So it's much more. So the tool set is much more complete and effective. But I think in the basics, you're still holding a tool in your hand, and if you're still bad at drawing, it doesn't matter if you have this tablet that lets you draw nice shapes and shadows and all kind of effects. If you're not good at drawing, it will still look like something bad. I don't want to say that word, but really. So take this example as something and try to apply it in other situations in life, in work, where in this case it's called generative design. So we as designers, we set up kind of the prerequisites, the context of the problem. So in this case, we're trying to design what is connecting the bicycle stem with the handlebar. And I guess if you think about your bicycle, it's probably just a tube there, right? A tube is easy to draw, it's easy to manufacture. But really what we just need to know is what's on the picture here. You're just saying, here's the handlebar and here's the stem. What is connecting those two pieces could probably be improved. The tube is probably not the best design. And you want it to be light, you want it to be strong, and you want it to be some different parameters, cheap to manufacture, for example. So let's just ask the AI how that would, design this piece instead. And it's actually iterating here on every iteration. It's optimizing against those parameters that we set up. So it's really so once it's done with the drawing, it's already stress tested and it's light and all that. And looking at that design, it looks really organic, doesn't it? It's nothing that we humans would design. So it's interesting how the AI comes up with something that draws from the nature, and there is something about it, and it's not that strange that nature has found a way of what is the optimized design. I mean, if we humans we use tools and we draw straight lines and curves and circles. But the other two here, maybe on the right-hand side, looks something like your kids would come home from preschool with. But the one in the middle there, it's kind of alien-like, I think, with the webs and all that. But this is much stronger and also lighter and cheaper to produce than the one on the left-hand side. And this is used by Boeing today when they design the walls in their airplanes, and they saved 50% of weight there. So really use AI to kind of connect the dots. We're setting the prerequisites, the context, the rules around it, and then let the AI help us. So we kind of together design it. Something that is not that organic is this game. And I think most of you have heard about this, AlphaGo, who beat Lee Sedol 2 years ago or something. And most scientists didn't think that would happen for another 20 or 30 years because you play by intuition, and that's nothing that machines are good at. I think the remarkable thing with this was when they came up with AlphaGo Zero. Zero stands for zero human knowledge. The first version was based on a lot of humans playing Go, but zero stands for zero human knowledge. So you just gave it the rules of the game, and then it kind of iterated and evolved to become this great player. And then they generalized it to play other games as well as chess and others. And just a couple of days ago, they released this Mu Zero, because Alpha Zero was good at playing 2 board games where you have a complete information of the whole game and also where all the rules were set. But that is not how life works. We don't have all the rules. We don't have all the information. It's changing. It's usually a combination of some rules. We need to live by laws and regulation in our society and life, but then everything else is changing. The market, the customers change. So this new algorithm is already producing better results than AlphaZero. But the interesting part was when it was iterating and evolving by itself and not based on human knowledge, it was playing this game in a completely different way. And the AI started teaching us humans how to play this game. And this game is the oldest game in history. It's 3,000 years old. And Lee Sedol, he has been playing this since he was 3 years old. And I meet so many companies that still say, well, I've been at this company for 20 years, and we've been around for 50, 100, or even 200 years, and we know kind of how to do these things. And I said, yeah, but you haven't been at your work since you were 3. Your company hasn't been around for 3,000 years. And still, there are AIs that can, help you and teach you new ways of solving your problems, your old problems, in new ways. When we talk about AI, one thing that comes up is usually predictions, predictive maintenance, or other predictive things. And most people think about that as something about predicting the future. But look at it instead of, use information and data you have to create new information that you don't have. And of course, you can use that to predict the future, but you can also use that to predict the present and also the past. So if you look at any problem as a prediction problem instead, then you can apply a lot of AI models on pretty much anything. And so look at the decision process we have when we come up with decisions in our head. It's really 2 parts. One is the prediction part. We look at the different alternatives. We take in the data and information we have from the past and from what we gather. And then we look at the different alternatives and come up with the best probability. And then we apply judgment on that. So judgment is more some soft values. What are our values? What are society's value, and some other things. So if we look at decision making at these 2 parts, you can see it's clear that we can use AI to do the prediction and humans to do the judgment, because we're not good at looking at all these different parameters that usually prediction uses, 100 or even 1,000 parameters to optimize on. We like to create abstract models to really simplify problems, but we lose a lot of information along the way there. So let's the AI do those things, and then we can apply our judgment on that and use that as a kind of a expert system. So I'm taking 2 examples here and how to think about this. This was Google engineers that did a project for about 3 weeks, I think, 2 data scientists looking at trying to optimize energy consumption at their data centers. Cooling down the servers are the ones the biggest energy thief at a data center. And when they applied this model, they could save 40% there. That's a pretty good business case. 2 people for 3 weeks, saving 40% on energy for Google data centers, right? So they deployed this and started using this. They still had humans as data operators and kind of, tweaking these different knobs. I think they had about 130 parameters that they could optimize on. And after a year or a year and a half, they said, why do we need these people here? The AI model has always been correct about how to optimize this. We can let the AI do the judgment here. And this is kind of the regular progression of things. And this will be use case by use case where we think we need a human judgment or when the AI can take over. Another example is this with cancer diagnostics. So computers are really good at understanding or recognizing pictures and patterns in pictures. 2015, the AI models were already beating humans, but at diagnosing cancer, the humans are still better actually at that. This was a couple of years ago, so it might have changed now. But I think the interesting takeaway here is when we use AI and humans together, we reach new heights. And this is showing that AIs are good at finding certain things and humans are good at finding other things. So it's a teamwork. We shouldn't try to create artificial intelligence that just mimics how we think. It's the same thing with airplanes. They don't fly the same way as bird flies. So we're good at finding certain type of patterns that are usually on a larger time scale, and AI is really good at finding these small nuances in big dimensions. So going back to this kind of decision model and try to break it down to a decision action chain, and look at any process in life or in your organization, and take the process, the different process steps, and what tasks do you have to have in each process, and see what decisions and action can you take. So this is usually a way that how we approach where we can apply AI and see, okay, what type of input do we have to this decision? Then we do prediction, and then we have judgment on that. And depending on the judgment, we take different actions. And the actions should always lead to an outcome that is measurable, so we can learn. This is crucial. There's actually a lot of times the outcomes are not measurable, and you can't really, and you actually don't even know what you're trying to optimize for. So this is not an uncommon pattern. So what different actors do we have in this chain? Well, on the input side, we have data, and we have heard that data is new oil or gold or anything. So data is important, that we have a lot of it, that is good quality, that is the right kind of data. So that is a must before we even start. And then we have this relationship between the human and AI. Who's doing the prediction? Who's doing the judgment? Like for self-driving cars, they have applied AI models that are predicting how to run the car, and then have a human driving the car, and then it learns from the human's judgment actually to be able to do the judgment itself through reinforcement learning. And then on the action side, is it a human that is going to perform the action, or is it a robot, or is it a soft bot like RPA or something? There's also a division of labor there, and then have this outcome. And I think it's important to really stress that again, that we have a measurable outcome, so that we can learn from that and really have a feedback loop there, so we can always be better. So this, I mean, if you take this and take this for any process or task you have, you can really stress this and do automation and everything. And this will be from a use case to use case basis. How big of a risk is it that something is failing? So, if you want to have human judgment there or not, or who is responsible. So where is this taking us? Taking the same analogy with self-driving cars, it's really, I can see this for organizations as well. Because there is nothing really that hinders us from going full automation for companies. I mean, of course, it will take a couple of years. It's not just 5 or 10 years, a lot of years. And we're probably at level 1 today, depending on industry, depending on company. But how do we take these steps to become this level 5 organization? And what does that even mean with a fully autonomous organization? Does it do business automatically with everything? Does it do its own business model innovation? And that is an interesting, theory. How can we build a model of the organization that the AI can work on? We need data. So this is just a conceptual model of how you could look at, a digital twin of the enterprise. And it could be on anything. It doesn't have to be an enterprise. It could be a society or a city or a country. So you need to have a really good understanding of your organization, and also put up what are the goals for the organization, what are our values, and then you build a layer on top of that to automate things, to generate new scenarios and do simulations on what would happen if we change this business model and so on. And you need to kind of interface with all the different, the world around you, the ecosystem, your clients, your partners, your different systems, your processes, and of course, all the devices. This creates this digital twin. But there is something lacking here. Even if AI can, recognize a cat in a picture, it doesn't understand that it's a cat. It's just been trained on looking at, millions of cats before. It doesn't know it's a mammal with, 4 legs and a tail. So we need to create this kind of semantic model of the world, how it all connects together. That's when we can start doing really interesting things. And there are companies working on this.
The vision of our Live Maps research is to bridge the physical and virtual divide to bring people closer together. To achieve this, Live Maps uses machine perception to construct multi-layer representations of the world, showing where you are in space, recognizing what things look like, and understanding the intrinsic meaning of objects. Connected devices, like smartphones and AR glasses, will scan the surroundings to create a live dynamic index, amplified by crowdsourced data, allowing the maps to recognize when things have changed and update automatically. Ultimately, our Live Maps research aims to empower people to connect and share in deeper, more meaningful ways. Whether it's improving how we access information, or understanding the context of a situation, to deliver shared experiences through augmented reality, or proactively serving up relevant information in highly personalized ways. Live Maps will one day transform how we all engage with the world, making it feel more immediate, more intuitive, more natural, more human.
So it's our favorite social company there, Facebook, trying to build a digital twin of the whole world and actually understanding all the objects in the world there as well. I mean, this is the vision for this is huge. It's much bigger than Facebook is today. But that's actually what is required to do this thing. But once we have that, it's really fascinating what type of things we can do. And they were talking about augmented reality, but no one was wearing any headsets like the HoloLens, which is great for specific use cases in the industry, but nothing that you would like to wear in daily life. So you would probably need to have something more, built into your eyes, like a lens or something.
All of this is made possible thanks to nano-retina technology. What it does is superimpose computer graphic generated imagery over real-world objects by projecting a digital light field directly into your eye. No, look, I insist, this is not dangerous for your vision. In fact, it's the total opposite. Think of it like getting laser eye surgery, but rather than getting a better vision, you're getting kind of like a supervision. Well, with Strange Beasts, you have a friend for life, really. So it's like having a dog or a cat, but without the life expectancy. And it's been proven that having a pet can help reduce anxiety in times of stress.
Walter, what did I say? Not on the sofa. Get down. Down.
Yeah, it's like straight from a Black Mirror episode or something, right? So, I mean, just imagine this, because, there is research being done on those type of lenses today. They have a couple of pixels, I think 16 pixels or something. It's not really rated as 4K yet, but, once we're there, we will live in a really strange world where people are interacting with, nothing, and we will all see different things. But really, the next step in this is also something that Facebook is heavily researching, which is called BCI, stands for Brain-Computer Interface. And I guess a lot of you have seen Matrix. It's pretty much that. You put a cable in the back of your head and you have a direct connection with the machine or computers. And this thing kind of looks clunky, so what you want to bring down is the size of this. And Neuralink is a company that was funded by Elon Musk, who just released that really ugly car, the Cybertruck. And so it's using these really, hairline, things going down into your brain tissue. This is pretty scary and weird stuff. And that machine on the right-hand side is what's going to implant that in your head. Any volunteers? And put that next to the quantum computer, and you feel like you're living in this really, it's back to the machines and steampunk world. But really, once we have BCI, we don't have to build all these interfaces. All the sensations we get directly into the brain. And all of a sudden, the lines blur between what is real and what is completely digital and fictional. We have people around us already that are kind of official cyborgs. That Neil Harbison, he wears this thing because he's colorblind. So he actually sees color through this thing that he doesn't wear. It's part of him. He has this on his passport, and he listen. He hears sounds instead of colors. And I think a lot of you have maybe read the books of Yuval Noah Harari, who's in Homo Deus and Sapiens, and he came up with this formula: biological knowledge times computing power times data equals the ability to hack humans. We already have now the computing powers through the quantum computer. We're creating all the data and the models for it, and we're getting more and more better at understanding our bodies. We can now suspend animation, we can freeze down, and we can stop aging and all kind of weird stuff. So this is taking us in uncharted territory, what it means being humans, connecting with the machines. And we're really getting into something that physicists call the multiverse. But they have a theory about, multiple physical dimension existing. But what I'm saying here, we don't need that, because we're actually creating, in the same physical world, we're creating multiple universes, because we will all interact and experience the world in different ways. When we are connected with the computers through maybe first lenses and then BCI, we will all get different sensations and different images of the world. We will be sharing a common ground, and then we will see imaginary pictures of, information of people that are not there for others. We can, share some of those experiences with others, and but some will be just our personal selves. That is a pretty weird future, but kind of connecting the dots, that's where we're heading. So to sum this up, I think everything that we can automate will be automated, because we're always driving down cost and we want to optimize. So think of this division of prediction and judgment we talked about, and how do we divide labor between humans, AI, and robots? What should humans still do? I think one good thing to take away with this is that now we humans can focus on the really important questions. What is right? What should we strive for? And then humans, we will evolve with new capabilities, augmented intelligence or augmented vision, and then finally kind of merging. So this is not AI taking away our jobs, or AI, killing us, or killer robots and all that. We're creating a new future where we are something else. So I wanted to end up with a pretty picture, so it feels good. A beach. I think this will lead us to a fully autonomous and hyper-personalized world, which both will divide us, because we will all have our own version of the world, but also bring us closer together, because I can choose to be on this beach with my friends even if they're not there physically, but they will see and actually experience the same thing. Strange world, but that's the future. Thank you.
Thank you so much, Conny. And I know that you would love to speak for 1 hour more about this. So we were discussing the future. And for me, it's really inspiring to think how technology can change the future for a better world. So what do you think? You mentioned Boeing, reducing weight. Do you see anything that could really make a big impact where AI can be that small?
I would say, we're taking small steps all the time. Everybody's looking for that. Where's the killer app for AI? Kind of, where are the? There is so much hype and so much promise. Where are the big advancements? But I think we have to be a little bit. So the vision I kind of laid out here, it will take some time. But we're seeing these things with suspended animation. Actually, the other day there was another model that could predict if you were going to die within the next year with just 85% probability, and it was seeing data that the doctors couldn't see in the same information. The problem was, though, that they couldn't understand why you were going to die. So look at this. The insights, if you get going back to that outcome. So if you know that you're going to die within the next year, but you don't know why, do you want to know? No. So we need to, when we get these insights about AI, we need to know, is it actionable? Is it something can I use this information to do something better? To change the world to the better or something? Because otherwise it's kind of useless information.
So, and we have discussed, we had a workshop this afternoon. I'm going to tell you more, we'll discuss that more. But what would you say about the industry? They have challenges. Do you see any, what's the key for them? Not to rush too far ahead with our discussion later on, but do you see any like big thing that they need to change?
Yeah, they need to change how they perceive and think about things. It's back to our as humans. It's not a tech. I mean, of course, we can't do everything with AI today, but it's not a technical problem. We can do so much more with what is available today, but it's we people that are afraid of change, and we don't like uncertainty, and that's fine. Everybody, we're like that, because we're used to be, apes living, in caves, and we're afraid, and that's how we're optimized to run away from risk, and we're still that species.